Good morning, friend. In last lecture, we have discussed about the exercise 8.1, and now in this lecture, we want to discuss related 8.2. So before we start exercise 8.2, we have to go through one important theorem, that is midpoint theorem. So one midpoint theorem statement is like that. Theorem 8.9. A line segment joining the midpoint of two sides of triangle is parallel to third side. A line segment joining the midpoint of two sides of triangle is parallel to third side. So if you will see the triangle, that is A, B and C. One triangle is there. A line segment joining the midpoint. So here it is a midpoint. Is parallel to third side. So EF, that is EF, parallel to BC. So you will see that if you observe the figure 8.25, in which E and F are the midpoints of AB and AC respectively, and CD parallel to AB. Here it is CD parallel to AB. Another way, actually, if I will take E and F, so we can write it here, but we have to prove this. So here it is an EF. We have to prove EF parallel to BC. CD parallel to B. Same thing, we can do it. Now here name of two triangle is given in your text. So we write these two triangle first. That is A, E, F. Another triangle is CDS. C, D, F. So here it is F, here it is C, here it is D. Now this according to the angle side angle too, so we can say here Z. If I make Z here, though, this is angle A. Again this angle. So one angle, that is E with D. So E with D. Another thing is again make Z. So is A with C. So A with C. And one side, because if it is a midpoint, here it is a midpoint, so two sides are equal. So that is why angle side angle, or here is also equal because it is a parallel. E is a midpoint, so this is two equal. So that way we can say that ASA rules two triangles are similar. If two triangles are similar, then EF is equal to DF. EF is equal to DF. These two is also equal. Two triangles already we prove similar, then another corresponding parts of CPCT we can. And BE is equal to BE, that E is equal to AE, because here E is a midpoint of AB. So E is a midpoint of AB, then AE is equal to BE. N is equal to CD. So AE, BE, here it is CD. Again, first I rub all the things, then we explain it. Then the question is, here we have to see. So E is a midpoint, so these two equal. And already we proved that two triangles are equal. So here it is equal to, so BE is equal to CD also. Therefore BCDE, therefore BCDE C D E is a parallelogram. Why? Already this is equal. So is a parallelogram. Therefore EF parallel to BC. So ED, actually it is ED parallel to BC. Therefore we can say that EF is equal to half of EF parallel to BC. Now here EF is equal to half ED. Why? Because here it is a midpoint. So EF is equal to EF is equal to half ED. But ED is parallel to BE. ED is parallel to BC. So we can say half BC. So it should be helpful in 10th standard also, that we have to remember. Anyhow, it is not important proof, but you have to remember that a line segment joined the midpoint of two sides of triangle is parallel to third side, and EF is equal to half BC. Now theorem 8.10. A line drawn through the midpoint of one side of triangle parallel to the another side bisect the third side. Line drawn, so it's a converse of 8.9. Line drawn through the midpoint of one side of the triangle is parallel to another side bisect the third side. Now we see the one example. Example 7. In triangle ABC, D, E and F are respectively the midpoint of side AB, BC and CA. So that triangle ABC is divided into the four congruent triangle. So first of all we draw the figure. So here that is given. Now these are all the midpoint, means what? Here it is equal to this. AF equal to FC and BE equal to EC. That we have to remember. So that ABC is divided into four congruent triangles. So if you will see that one, here we can say it is 2, here we can say 3, here we can say 4. So four congruent equal triangle generated. How that is important for us. So again we apply the theorem 8.9, that is midpoint theorem. So if you will see, there are three parallelograms we can generate it. If you will see properly. So A, D, F and E. Another is that is D, B, F and E. If you will see, there are, so 1, here it is 1, 2, 2, 3 and one more. So D, F, E, C, 2 with 4. So four parallelograms here they are generating, and according to midpoint theorems, all four, these are all the parallelograms. So in parallelogram we'll divide into two equal triangle. So we can say that the four congruent triangle generate. But now we have to see by proof wise. So first, S, D and E are the midpoint of side AB and BC of triangle ABC. So according to the theorem 8.9, DE is parallel to. So here if you will see, DE is parallel to AC. So here it is parallel again. Same thing we can EF parallel to AB and DF parallel to BC. That way we can do it. So therefore ADEF, if you will see that ADEF, here it is a one parallelogram. BDEF, BDFE, again one parallelogram, and DFCE, DFCE. So here four parallelograms already I constructed. So all are parallelogram. Now DE is a diagonal of parallelogram. DE is a diagonal of parallelogram. So this triangle already I am draw it here. BDE. So BDE is equal to EFD. So EFD. So here 3 is triangle 3 is equal to 2. Now DAF. So DAF, that is 1, is equal to FED. So FED, that is 2. EFC, that is 4, is equal to FED, that is 2. So we can say that 1 is equal to 2 is equal to 3 is equal to 4. So that way 4 triangles we have say they are equal. Now if you will understand it properly, then we go for next slide. Now we start exercise 8.2. There are 10 sums. So out of 10 sums, I am explaining 5 sums. ABCD is a quadrilateral in which PQRS are the midpoints of sides of AB, BC, CD and DA. Here question, you see the figure. AC is a diagonal. So first we have to see the figure. So ABCD is a one of the quadrilateral. We show that SR is equal to SR parallel to AC. So SR parallel to AC, that we have to prove. SR is equal to, so midpoint theorem, if we will prove that, then it is possible. And PQ is equal to SR. PQ is equal to SR. So we can say it is a parallelogram. So first of all I have to draw one triangle. From here we have to do one triangle. So in triangle ACD, so if you will see triangle A, C and D, so we can draw one triangle. That is A, C and D. So S is a midpoint of AD and R is a midpoint of BC. So SR is equal to half AC according to the midpoint theorem we can say. So SR is equal to half AC. Same we can draw now one more triangle, that is A, C and here we have to write B. Now P and Q are midpoint. So if we join, then PQ is equal to half AC. Let me see that. So now here ACB, right? ACB. In triangle ACB, P is a midpoint of AB and Q is a, so P is a midpoint of AB and Q is a midpoint of BC. Hence PQ parallel to AC and PQ is equal to half AC midpoint theorem. So from 1 and 2 we see that SR is equal to PQ. So SR is, so it already here it is proved. First prove. In second, PQ is equal to SR. So from first and second we can say that SR is equal to PQ. So from first and say PQ is equal to SR or PQ parallel to SR. So one of the pair, so we can say it is a parallelogram. Now in triangle PQRS, PQ parallel to SR and PQ is equal to SR. Hence PQRS is a parallelogram. So it is easy if you will understand it properly and read it and listen it. तो ये एकदम easy है theorem. So I think you have to write एक बार लिख लो अच्छी तरह से. That way you have to write in fair book also. Now third question. ABCD is a rectangle. PQR as the midpoint of side AB, BC, CD and DA respectively, so that PQR is a rhombus. So that PQRS is a rhombus. So here we have to do the diagram. We have to prove that inside PQRS is a rhombus. Here ABCD is given as a rectangle. And so midpoint theorem we have to use. So first one triangle ABC. So if we will see that triangle ABC, so we have to draw here one. A, B and C. P is a midpoint of and Q is a midpoint of. So if I will join this, then again PQ parallel to AC according to midpoint theorem and PC is equal to half AC. So here similarly in ACD, if you will see properly here, ACD, A, C and D. So we can draw it here ACD. That is why A, D, C. So again S is a midpoint and R is a midpoint. If we join, then midpoint theorem again, SR parallel to AC and SR is equal to half AC. So from first and second we say that PQ parallel to SR. So PQ is equal to SR. So PQR is a parallelogram. So from ABCD is rectangle, we have convert into a parallelogram first. Why? Because we want to prove that ABCD is a PQR is a rhombus. So from ABCD rectangle we convert parallelogram PQRS. So ABCD is rectangle given, we convert PQR is a parallelogram. Now PQRS is a parallelogram, we have to prove that it is a rhombus. So for rhombus we have to prove that AB is equal to PQ. So first I rub all the, then write again. Now what we have to prove? Already we proved that ABCD PQR is a parallelogram. Now what we have to prove? PQR is a rhombus. So if we prove that PQ is equal to PQ is equal to QR, if I will prove, then already PQ is equal to SR. So three sides are equal. So already four sides equal and we can say it is a parallelogram. So now we here similarly in triangle BCD. So you will see that triangle BCD. So here it is B. We draw one triangle, that is BCD. Now in triangle BCD, Q is a midpoint of BC and R is a midpoint of CD. So we can say that QR is equal to half BD. So QR is equal to half BD. QR is equal to half BD. But given AC is equal to BD, why we can say it is a rectangle? Because of rectangle. Because of rectangle. So AC is equal to BD. So rectangles, if it is a rectangle, then diagonals are equal. So instead of BD, we can write AC. So QR is equal to half AC. So if you will see PQ is equal to half AC, SR is equal to half AC and QR is equal to half AC. So PQ is equal to QR. So parallelogram whose adjacent sides are equal, it is a rhombus. Hence PQR is PQRS is a rhombus. So that way we can explain it. Question number 3. Now question number 4. ABCD is a trapezium in which AB is a trapezium. AB parallel to CD. And BD is a diagonal. BD is a diagonal. And E is the midpoint of AD. E is a midpoint of AD. A line is drawn through the E. Line is drawn through the E parallel to AB. Intersect BC at F, so that F is the midpoint of BC. Now here ABD, see the triangle ABD. So here it is a one triangle A, B and D. E is a midpoint of AD. E is a midpoint of AD. And EG. So here we have to pick one point G. So EG is parallel to AB. So G is the midpoint of BD, converse of midpoint theorem. Now similarly we can say BCD. So B, C and D. D, C and D. Now G, in BCD, G is a midpoint of BD here. So here what is F? So G is a midpoint of BD, then again GF parallel to CD. So F is a midpoint of BC, converse of midpoint theorem. So we have to prove that F is a midpoint of BC. So it is not too much hard, it is easy. Now question number 6. Show that line segment joining the midpoint of opposite side of quadrilateral bisect each other. So that line segment joining the midpoint of opposite side of quadrilateral. So here one is the quadrilateral is given, line segment joining the midpoint. So these are all the line segment joining the midpoint. Bisect each other means they are bisect. So that we have to prove. So first of all, ABCD is a quadrilateral, PQR is the midpoint. So according to the midpoint theorem, we can take easy one triangle ACD. So ACD here. So first we have to remove everything and then we do ACD. A, C, D. S and R are the midpoint. So S are parallel to AC and S are half AC midpoint theorem. So that is equation number 1. Now here P. So here again it is a mistake. You have to write B. So again same triangle we can draw. That is A, C and B. P and Q are the midpoint. P is the midpoint of AB and Q is the midpoint of BC. So hence PQ parallel to AC and PQ is equal to half AC midpoint theorem. So equation 1 and 2 we say that PQ parallel to SR, and if PQ parallel to SR then it is a parallelogram. So in quadrilateral PQRS, PQ and SR is equal to, so hence PQR is a parallelogram and diagonal of parallelogram bisect each other already is a one of property. So from quadrilateral we have proved that it is a parallelogram. So parallelogram, one of the important property is that, so equation 3, PQ parallel to SR, PQ is equal to SR, so because of half SR is equal to half AC, PQ is equal to half AC. So in quadrilateral PQRS, PQ parallel to SR and PQ is equal to SR. Hence PQRS is a parallelogram. So here it is PQRS is a parallelogram. So in parallelogram, diagonal always bisect each other. Now ABCD is a triangle. At C, a line through the midpoint of M of hypotenuse AB and parallel to BC intersect AC at D. So here it is a parallel. So midpoint theorem we can apply. D is a midpoint of AC. D is a midpoint of AC. MD parallel to MD perpendicular to AC means it is a right angle. And DM is equal to CM is equal to MA is equal to half AB. So first of all, in triangle ABC, M is a midpoint. Triangle ABC, M is a midpoint. So DM parallel to BC, converse of midpoint theorem. So D is a midpoint of AC. So hence it is proved. Now if you will see that ADM is equal to ACB, ADM, so here it is 90, and ACB, here again it is 90. So corresponding angles pair are there. So MD perpendicular to AC, MD perpendicular to AC. Now third, in triangle AMD, so AMD, so we have to draw one triangle here, AMD and CMD, CMD. Now here it is AD is equal to CD, AD is equal to CD, because here D is a midpoint of AC, so here it is equal, and ADM is equal to CDM, ADM, so 90 degree, CDM 90 degree, hence two triangles similar. So if two triangles are similar, then AM, because here it is common, so AM is equal to CM. So two triangles are similar, therefore, but AM is equal to half AB. Already we know that AM, because M is a midpoint of AB, so AM is equal to half AB. But we know that AM is equal to CM. So instead of AM, we can write CM. So AM is equal to CM is equal to half AB. So that way we have complete this exercise. Only two exercises are there, and you have to complete anyhow in your fair book.